F size, fit per tooth. Okay, he say fit per tooth. Okay. I'm going to review the correct answer now. Anybody want to give it a try? This is the last question, last time drive. And I hope you don't want to miss the picture inside. It's very nice. Okay, 3, 2, 1, 0. Okay, that's the answer. Chip thickness. Okay, not fit the tooth, not fit the tooth. Okay, not the FZ. It is the chip thickness. Okay. Congratulations. Thank you. Okay. If you say it is the FZ, okay, you might be correct if your cutting step over is 50%. If your side step is 50%, yes, the chip thickness, the green one is the chip. The thickness of the chip is equal to FZ. Okay? Yeah. But what happens if I using only 10% of the cutter as a side step to machine the part? So what is the actual chip thickness now? Okay? Do I have a figure here? Yeah. 50%, 0.1. 0.1. And for a annual 10 mm, based on my experience, it is I can see it is a very good chip load. If you put if the thickness is 0.1, that's if I'm going to do some cutting, I'm going to use 0.1 for 10 mm. Okay. So within the same RPM and feed rate, okay, the difference is the side step. So if 50% is 0.1, is equal to FZ. But if this side step is 10% of the cutter diameter, it is now 0.059. Okay? The chip thickness actually reduced a lot. And this reduction of chip thickness is actually not good for the cutters. Okay? I would say some rubbing might occur if serious. Okay? The cutter will become wear more faster. Okay? And you only cut small amount of materials. Yeah. This is the theory. So we must, in theory, is that we must always, if our target chip load is 0.1, we must always make sure the chip thickness is always equal to 0.1. Okay? It can be 10% of side step. It can be 50% of the side step. Okay? This is the theory. And how to increase the chip thickness if I use 10% of the diameter as a side step? Anybody knows? Sorry? Yes, increase free rate. Sorry, I'm out of the dump drive. Okay. Oh, you want to take my shirt? Okay, just kidding. Yeah. Yeah, you should increase the free rate. This means that if you are using 10% of the side step to machine the part, okay, you should increase the feed rate. Okay? Or else your machining is underperformance. Underperformance. Yeah. Okay, next. Okay. This is now E11 we have a calculator like that. To let you calculate what is the actual chip thickness. Okay? You can see this value here. I put 0.1 feet per tooth here, and the side step is 1 mm. Okay. And if the feed rate and RPM I'm not changing, I remain the same. You can see the actual feed chip thickness here is only 0.059. Okay. So the correct method for machining is we should increase this value, increase this one to be 0.1. So next picture, I increase this one, 0.1. You can see what's the current feed per tooth. It is 0.1698. Okay? Already increased. With this feed per tooth, I'm actually cutting at 8,600 feed rate. 8,600 feed rate. Of course, my cutting speed is 400. Let's assume. The old one is only 5,000. So from this calculation, simple max, okay, you have what? The feed rate of your cutting, okay, is increased by 70%. Okay, we call this high feed machining, not high speed machining, okay? High feed machining. That means we don't control the cutting speed to be very high. We actually do high feed. Okay. So if I only cut 10% or around 10% using of the tool to cut, actually I can go faster, okay, and reduce by 70%. And I'm cutting only one layer, okay. So with these 2 points, this point and this point, I am very confident in theory, okay, we can save your cycle time up to 80%. Okay, what you need is a spatial cutting strategy to do it. Yeah. So, is it possible? Do I lie something? I don't tell lie, right? Okay? So, it is possible. It is possible. So, do you want to know what is the strategy? Yes? Okay, good. Look at that chip. This chip is actually, I get it from one of my case study, okay? My test cutting. You can see the chip is very long because I'm using a 2D as a down step to cut, okay? So this cutting strategy now is in Cimatron E11. Cimatron E11. Okay? Do you want to know more about how this strategy works? Yeah? Do you want me to continue to explain more about how this VoluMill works? Yes? Okay? So thank you for the interest because limited time. So if you really need to know more, please contact Mygrowtech. Okay? We will send our engineers to explain to you in a very detailed manner. Okay? So I'm not going to talk about this now because limited time. Okay? Okay. Next, I'm going to share with you some actual case study that I've done by myself. For me, I like the machines. Okay, any machines. I like challenge. Okay, for me, I don't like economic. Okay, I only like technicals. Yeah. So let me share with you this one. This one first. The latest case study that I've done is this one. I'm going to cut a 3D part. 3D part, okay? This is actually a punch for some stamping die, okay? And the material is some kind of tool steel, okay? And 35 to 40 HRC, very hard material. Okay, and the tool is carbide tool with the black coating, yeah. And this is what I did. The diameter is 12 mm, 12 mm diameters, and I'm actually using 2D to rough the part for the VoluMill. So if you compare to the old way, this is the old way. The downside only 10% to 20%. And the machine that I'm using is not a very expensive machine. It is a very cheap machine that the maximum RPM only 6,000. Okay? This shows you that your old machines still can perform. Okay? And yeah. Due to the machine and things like that, the maximum view rate that I can go is actually 1008. Okay? The old way that the customers using the data, they are using a 1000 view rate to cut. Okay? So this is the cycle time that we get. Okay? Our cycle time for this roughing process is around 30 minutes, 58 seconds. And the old way is nearly 1 hour. Okay? You can see a big improvement in cycle time. So this is a new machine simulator in E11. Okay, in E11 we already update, add in one more simulator, and this is the actual cutting. You can see now it's cutting at 2D, 24 mm. And one more thing, why my feed rate I'm putting only 1008 is the machine don't have air. We have to use the air gun to blow away the chip. That's why I don't dare to go faster. But if the machine have air, okay, actually I can go for 2008 instead of 1008. And do you hear the vibration sound? That is because the clamping is not nice. The face is not grind. Yeah, the clamping issue, not the machining issue. Okay. So part like this, if you have small machines, okay, I don't think you're going to use a big face mill to do it, right? That's why. Part like this, you still need to use a solid end mill. So solid end mill not just for finishing, yeah? It is for roughing also. So the movie is a little bit long. Just go a bit more to the end. Yeah. Yes. Yeah. Yeah. Because this is a 3D part. If I use a downside of 24 mm, you will have a big step remain. Okay. Currently, the software will automatically clean up the step to make it smaller. Okay. And this is automatic part of the residue. Yeah, for 3D. Okay, that's it. Let's look at the case study number 2. Look at the slide. Next, I'm going to explain the case study.